So hello everybody and welcome. I'm so glad you could make it here today. I hope you had a good morning and that you enjoyed the keynote this morning. Everyone enjoyed the keynote? Good stuff. So my name is Neil and I'm MC for today, and we're going to introduce a wonderful bright young guy for the first talk. Before we do that, a few bits and pieces we need to take care of, if that's okay. So there's just the usual stuff like the fire safety instructions. So if the alarm goes off and stays off, then we need to leave the bell and go down to the quadrangle. Just follow the green walking man signs to the nearest exit. And we assemble on the south side of the quadrangle and remain there until instructions otherwise. Is that okay with everybody? Yeah, we're all familiar with that. So also I'd like to just, if your phone's on at the moment, turn to silent or turn to airplane mode so you're not getting any calls or any call during the talk itself. Okay, so the talk is half an hour, running a few minutes over. I think that's fine. So we'll take a few questions after the talk. If we've got extra questions, then there's an open space, open speakers corner downstairs beside where you registered, so we can have discussions with the speakers after that if you've got further questions. So apart from that, the only other questions thing I want to cover is that there is there's a room out here to the side, and it's going to be demos, room 4. So if you want to see some of the demos this morning, as far as lunchtime between talks, you can have a look at those as well. Okay? So let me introduce Dominik Picheta. Is that Picheta? Nearly got it right. So Dominik is a very interesting character. It's almost like this conference was built for people like Dominik, because what we want to do is inspire people to share what's happening in the community, to encourage young developers to become involved in developing communities, which I think you classify as one of these. So Dominik has already written a book. It's in press at the moment, you can buy it, about NIM, the NIM programming language, and his talk today is about NIM programming language. So give a warm welcome to Dominik Picheta.
Okay, thank you for the warm welcome, and thank you for coming to this presentation. I know there's lots of great talks out there. So yeah, I've been a core developer of NIM for the past 5 years, and I've kind of started using NIM 7 years ago now. So let's just get into it because we don't have much time, and I've got all the slides. I probably need to skip some, but yeah, let's go. So first of all, what is NIM? NIM is an incredibly fast systems programming language that is expressive, extensible, and really fun to use. At the bottom you can see it's a Hello World example. Now don't be fooled by that. It's nothing like Bash. The echo is just like a Python print, and the only reason that it's echo instead of print is because one has character to type, and the creator loves his loves not wasting time on typing. Anyway, let me just go quickly through these characters. Like, so it's fast. It actually compiles to C. So the language itself, the programs that are produced as a result of compilation are within 1% or even as fast as C programs. It's a systems programming language, which means it allows you to take full control of the hardware. It's expressive. I mean, you can see by the Hello World, it's just one line. And it's extensible, so the creme de la creme of NIM is metaprogramming. It allows you to extend the language. I'm not sure if we'll have enough time to talk about metaprogramming in NIM, but that's the best thing about it. So who develops NIM? This is a big question because a lot of NIM's competitors, Go, Rust, Swift, are backed by really big companies, Google, Apple, and Mozilla. Well, NIM is volunteers. Now that might not be an exciting answer, but I think it's amazing to see so many bright people just doing this in their spare time, including myself. And over time, they've created more than 2,000 pull requests on GitHub. They've solved, as a result of that, more than 2,500 issues, and they've created more than 500 packages. And the package manager is still quite young, so this is just the beginning. And finally, we also have been getting some monthly contributions through Boundary Source. For the past 12 months or so, we've been getting pretty regular 1,500. It's not much, but it has allowed us to hire a part-time person to work on the compiler and other things. So another question, why NIM? Well, you can take that from different perspectives. You can say, why am I using NIM, or why was NIM created in the first place? I can't answer the second question because I didn't create it myself. I'll let the creator, Andreas Rumpf, answer that. But I can answer why I'm using it. And the reason is that there's just no better language, in my opinion. You can, talk to me about that later, and hopefully I can convince you that that NIM is the best language for this talk. So, first of all, let me whet your appetite a little bit with a demo. Now, this demo is a game, something that I've created over 2 weekends or so, a bit longer, and it runs in the browser. It's written completely in NIM, and it's Snake. So, I'm not sure you can see it quite well. You guys can actually join in. This is actually a little twist on Snake. It's multiplayer Snake. So, if I type in my name and press play, that's a live demo, so things could go wrong. It's a little Snake game. You can see on the right, there's somebody who actually beat my high score earlier, 30. I reset the high scores. But anyway, if somebody wants to join, they can go on this URL and join the game, and then you would see another person joining on the high scores there. Oh, there's somebody. And there's, okay, cool. So that's just a little demo. Now, you might be asking yourself, how is this running in the browser when NIM compiles to C? Well, NIM also compiles to JavaScript. And that's the beauty of it. I actually have a lot of code that is common between the stuff that's running in the browser and the stuff that's running on the server to sync the high scores. And that's a big advantage of using them. But of course, I'm not very talented. I mean, this game it's not the best designed game in my opinion. There's no really pretty graphics or anything. So let me show you something that other people achieved. This is Vector 2089, and this game has actually been recently greenlit on Steam. It's by an Australian developer, kind of working again in their own time. It's written completely in NIM, as far as I know, and I've played it. It's actually really cool, and you should check it out. If you want to check it out, just search Vector 2089. So let's get into the language now. Some of the goals are really not really goals in particular, more like even characteristics of the language now. The language is actually rather old now. I've been working on it for the past 7 or 5 or 6 years or so. But okay, so let me just go through it. We wanted a language that has the efficiency of a statically typed compiled language with the ease of programming of a dynamic language done right. And the reason I added done right was actually Go had the same goal, and I think that NIM achieves it much better. I will show you how in a second. Again, reduced typing, that's a big goal. That's something that the creator really loves, so you have no more of that foo.foo from namespace foo, and you have to keep repeating yourself all the time. And it's fast, and that's not only from the program side, it's also compilation speed. So you want to have a fast language. Go is again famous for that. And I think even though NIM maybe doesn't get close to it, or I should say it does get close to it, but it doesn't beat Go, but it is quite close to the compilation speed of Go. We wanted to reduce boilerplate in your code. That's again to do with reducing typing. And we wanted dependency-free programs, ones that you can just take and put on somebody's computer without having to install any libraries or like Python interpreter or the JVM and stuff like that. And cross-platform programs, of course, and we want the programs to be type and memory safe. So the implementation of the language, there's currently only one implementation. The official compiler written in NIM, it's written completely in NIM. And as I said, it compiles source code to C, and it can even compile it to C++, Objective-C, and JavaScript. And it's very important to note that when you're compiling C++, the usability of that is that you can interface with libraries written in C++, and when you're compiling to Objective-C, you can actually interface with iOS libraries or macOS libraries, and that's a big thing if you want to target that platform. And blazingly fast compilation speed. And no need for makefiles, that's a big one again. If you're coding in C, if you've ever coded in C, you know that you have to write makefiles to compile each file separately. And that's just a real bother. In this, you just type in nim space C file, and it takes care of all the dependencies, compiles them for you. Now I'll skip this because we're really low on time, but it is very fast. It takes like less than a second to compile a hello world application. It takes maybe 6 seconds to compile the compiler itself, which is like 130,000 lines of code. So, and it gets even lower because you have caching. The C files that are generated are cached, so if you modify one file, it doesn't mean it has to recompile all of it at once. So let's look into, oh dear, well hopefully see most of that. Syntax basics. So at the top we have a constant, it's an integer. Now note that there's no need to specify types, just typing in 2024 and setting that to the constant n. We have a string, and it's a Unicode string. Nim supports Unicode strings natively. You can even have Unicode in your variable names. You can even put emojis in there. Then next we have a variable, x and y. In this case, we're not initializing it, so I just put float there to say that that is the type of x and y. And you've got a character. Note that there's single quotes versus double quotes there. The single quotes mean it's a character, the double quotes mean it's a string. And later on we define and use a type. And what's important to note here is the ref. Nim is a bit different in that there isn't as much emphasis on object-oriented programming. You just define sort of like type structs like you would C, for example. And yeah, so we just construct it here. We set the T objects A field 42 and the B field to 0, and then you have control structures. So you can see that the syntax is kind of sort of like Python as well. You have significant notation for the control structures. So values and types, again, I'm going to cut off, sorry about that. We have arrays, an array at the top, an array of strings. Then we've got numbers. This time it's a sequence. The difference between an array and a sequence is that an array cannot be resized, cannot grow. A sequence can, so you can see I'm adding 4 there. We have a phone book, a simple hash map that is. It's called a table in Nim, so we use a toTable function to create the actual hash map. And then we define an enumerator. Enumerators are really useful for just assigning a name to a value. And then we also have sets in the language, so you can have this really efficient data structures in the language and test it to see whether a flag or whatever is in it, which is really useful. And so the emphasis here is that, again, you don't have to specify the types for each of these variables. So if I can obviously, if I really want to, but the language itself infers all of it on its own. So I'm just adding them here. So names is an array, and you can see that it's got 2 in there, which shows that you have to specify for the array how many elements are in it, and it's two strings. So there's string values in there, and you've got a sequence, just a type, ints, and you've got a table mapping from a string to a string, and you've got a set of days for the set. And then procedures. So I mentioned that Nim doesn't really do object-oriented programming. It supports it, but it emphasizes a much simpler procedural programming paradigm. And in this case, you're sort of instead of specifying like a class and putting all the methods inside that class, you're just defining a type, and then you're defining procedures that work on that type. And the important thing is that you can actually call it as if it was part of a class, as you can see here. So just to go through it, how much time do we have? So we define a point object with an x and a y field, the asterisk there means that the type is exported to the package, and it also means that here and here. And obviously we define a scale procedure and then an out procedure, and we do an assert to make sure that it works. Another thing to note, again, we're reducing typing. We're importing a math module here, and some of you might really dislike that. It is sort of controversial, but all I can say is, what I'm talking about first of all is that you don't have to specify math dot square root there. You just do square root. The language knows where it's coming from. And in Python, it's the other way around. You have to tell it which namespace it belongs to. But in name, it's different. So we're just typing again. And yeah, you can. This kind of model allows you to place a procedure on any type, so you can actually extend the procedures that are defined on strings. And I should say, sorry, procedures in NIM are just functions or methods. They're known as that in other languages. But again, you can just call it like this, or like this, whichever you prefer. And we also have procedure overloading. This allows you to define a procedure of the same name with different parameters, and the compiler will decide which one to call. So in this case, we're telling it to call say procedure with a count of 5. And obviously it'll output computer says no 5 times. And we also have generics. Generics are really powerful. They allow you to do a lot of things with less code. They reduce repetition. In general, they're just really good. So we now support them fully. In this case, we're extending the say procedure to accept any type, and we're passing a number. In this case, a binary number, literal, which is just an int anyway. And metaprogramming. So metaprogramming, like I said, is the creme de creme of NIM. It's no specialty. What is it? Well, Wikipedia defines it as metaprogramming is the writing of computer programs with the ability to treat programs as their data. It means that a program could be designed to regenerate, analyze, and/or transform other programs. And the great thing about metaprogramming is that it allows you to reduce boilerplate significantly, and it's implemented in NIM via generics, templates, and macros. And it also allows you to implement domain-specific languages, like this one here. It's actually a web framework called Jester, and it allows you to specify routes for your web application in a nice syntax. And this is all implemented using macros in NIM. And another thing that kind of ties into metaprogramming in NIM is you've got combative execution. This allows the compiler to actually execute a large part of the code for various reasons. In this case, for example, we want to call the Fibonacci function with a parameter of 20, and we want to assign it to a constant fib20. And then we want to output it. Now, if this was just a variable, it would actually calculate it at the start of the application. But because it's a constant, it means that when you're compiling the application, the Fibonacci function is executed, and the number 6765 is computed and then put into the executable. So every time your user runs the application, it doesn't have to recompute the Fibonacci, the 20th number in the Fibonacci sequence. Yeah, so other goodies we have in NIM, iterators, concurrency via async await. It's similar to C#'s async await, but it's implemented fully in using macros. Exceptions, something that Go doesn't have, unfortunately. Effect tracking, and this includes the ability to track where exceptions are raised in which procedure, and to, for example, say, okay, I don't want my function to raise any exceptions, and the compiler verifies that when it compiles your application. Soft real-time garbage collector, this is good for games when you want to reduce latency from GC pauses. We have an official package manager. We have concepts and interfaces which are still kind of being worked on in this rich standard library as well. That includes anything from an HTTP client to everything in between. So, it was mentioned, I've written a book on NIM. If you want to learn more, I would appreciate it if you check it out. If you check out the book and have a read. I have actually a coupon to offer, 40% off. If some of you want to note that down and take a picture, I'll tweet it as well if you want to follow me. And yeah, so this is it. Thank you for listening. I hope that you will consider trying out NIM. I hope that you find it interesting now that I've talked about it. And yeah, these are some other links. Obviously, in the website, you can learn NIM on there. You can ask questions on the forum, the NIM subreddit, NIM on IRC as well, and on Gitter. And then you can follow myself or the NIM programming language. Okay, thank you for listening.
Any questions?
Yeah, one. How do you handle ambiguous imports?
So when you're compiling your program, you will get an error just at compile time telling you this is ambiguous from this module or from this module, and you will have to specify the namespace that it comes from.
Any more questions? One question I have: if people want to get involved in the NIM language and the whole project, how do they get? How would they? What's the easiest way of getting involved? Through Git?
Well, yeah. I mean, if people want to get involved, you can join Gitter. I'm not sure if you guys are familiar. Gitter is sort of like Slack, or it's just like a chat room where we have lots of NIM developers. If you just join there and ask, I want to contribute to NIM, how do I do it? We can help you out.
Any more questions? No? All right, thank you very much.